Hello. Today we are going over Newton's laws and along with them, momentum and inertia. Newton's discoveries have made a huge impact on the world with his theory of gravity and his laws of motion. Let's start with Newton's first law, or what it's commonly known as the law of inertia. Newton's first law of motion states that if an object is at rest, it has the tendency to stay at rest, and if an object is moving at a constant speed, it has the tendency to keep moving. This is called inertia. These objects will continue to move or stay at rest until acted upon by an opposing external force. Here we have a backpack. If the backpack is at rest, it will stay at rest. However, if the backpack is started in motion, it is forced to move and it will start to continue in motion. When the force is stopped, the backpack will continue to spin even after the force has been stopped. This demonstrates Newton's first law and inertia. Next, we have Newton's second law. Newton's second law states that acceleration happens when a force acts on a mass and that the greater the mass of the object being accelerated, the greater amount of force needed to accelerate the object. This law can also be demonstrated with the equation force equals mass of the object times the acceleration, or the measure of change in velocity during a period of time. For example, if a ball with a mass of 2 kilograms is kicked and accelerated to 16 meters per second, or 16 meters per second squared, the force would be equal to 32 newtons. Another example is if we lift this bucket and we use a certain amount of force, but when we fill the bucket with backpacks that increase the mass of the bucket, we have to apply a greater amount of force that is proportional to the greater mass of the bucket. Then, we have Newton's third law. Newton's third law states that for every action, there is an equal and opposite reaction, which means that when an object exerts a force on another object, the second object exerts the same amount of force on the first object, but in the opposite direction. So, if we were to bounce this ball with a certain amount of force, the ground will apply the same amount of force that we applied to the ball. But if we were to bounce the ball with a greater amount of force, then the ground would apply that exact same force, but in the opposite direction. And lastly, we have momentum, which is a measure of how hard it is to stop a moving object. Momentum is represented with the formula P equals m times v, which means momentum equals the mass of the object times the velocity of the object. For example, if you were to throw a ball to someone and it had a mass of 10 kilograms and a velocity of 2 meters per second, its momentum would be 20 kilograms times meters per second. For an example, if we have this chair with a little amount of mass and acceleration, it is easy to stop. But if we increase the mass and acceleration, it becomes harder to stop, or, in other words, the momentum increases. Thank you for watching our educational video. I'd also like to give credit to my group mates Emmy B and McKenna H.